What's up, guys? It's me. We are back at the grind again. Today will be a really short stream because I need to get to the university. Actually, I should probably not stream right now, but yeah, well, regardless, we'll stream and yeah, I probably should not stream right now. Okay, it's a quick stream. Maybe I will make it in a video. We'll just go over my optimization of Sieve of Eratosthenes. So first of all, what's going on? Why yesterday wasn't a video? Yesterday I was busy. Yesterday I went to university. Yesterday I was completely scorched, okay? I rolled over by the online assessment from one of the trading companies I applied to. And third of all, I've done leetcode off stream, so I've grinded. And fourth, I've created this optimized, well, for me it's optimized, but probably it's really not optimal version of Sieve of Eratosthenes algorithm for finding primes. So let's go over how it works. What's the task, first of all? The task is to create a Sieve of Eratosthenes algorithm and time it up to the millisecond. So it's not that constrained. However, you must not allocate more than 20 megabytes of memory. That's pretty much it. And the max number you are going to is 70 million, so it's also not that high. However, it might pose some challenges in the future. So 70 million, as you probably all know, if you have 70 million integers, that is way beyond 20 megabytes, okay? So we have to tackle this part first. So what I thought about is, okay, instead of making it on integers or something like that, we will do bits. Single bit is single number. And when the bit is set, it basically means that that the number is prime. That's what it means. No, when the bit is set, it means that number is not prime. I'm sorry, number is not prime. That's what it means. So when the bit is set, number is not prime, yeah. And so when the bit is not set, when the bit is false, then the number is prime. So as you can see, what we do is we define a bracket size, and the bracket size is basically how long is the integer here, so 32 bits. And then we create some number of brackets. I'll talk about this soon, why we use this. This is interesting. I'll talk about this soon. We create some max number of brackets, and then we create all numbers array, which basically will store all numbers. And why are we doing it here, not in the main function? We are doing it in a global scope. I mean, kind of global scope. It's really a namespace, but this is a global scope, to be honest. Because the standard of C++ says that what is in the global scope should be zero initialized. And how it is done under the hood is really interesting, because this is in BSS section of the code, section of the memory of the program, which is zero initialized also because the pages are zero initialized. And yeah, it's just yeah, I think it's just an interesting fun fact here. So yeah, and there is some sieve limit I'll talk about soon too. So those are a couple operations that you might take a look into. Honestly, I authored them. They are not copied from ChatGPT. Everything you see here is pretty much mine. Those are operations that get bits, set bits, and that's all. There's a lot of shifting because I believe it's a little faster. For example, this is basically division by 32. If you look at actual compiler, if you look at actual compiler here, and if you, instead of dividing it by instead of shifting it, you divide it by 32 here, what you will notice is here, right, we are here. Is SC shift right by 6. So we are shifting right by 6 because there is an idea that shifts right by 1, then we shift right by another 5 here. So this division is kind of optimized into being a shift to the right. So I mean, we can honestly shift to the right here to be more kind of compiler wise. I mean, we don't really have to do this, just fun, looks fancy, right? So what we do is we iterate. I mean, the algorithm is really simple, right? We just iterate through the number. We start from the number 2, right? Because 0 and 1 didn't really count. We start from number 2, which is prime. We mark it because it's well, we are not really marking it, right? We do not mark it, we just see that it's not marked, and then what we do is we kind of iterate over the next numbers, and over its, you know, how do you call it? Wielokrotność. Over its multiples, yeah. You iterate over its multiples like that, and thanks to this, you arrive at, you kind of mark out every composite number. Now, you start from 3 because all composite numbers are odd, so you don't really have to start from 2 and, you know, erase all even numbers. That would be like also performance hindrance, right? So you start from 3, and then it's like 9, and then you basically start iterating. You also iterate only to Sieve limit, and Sieve limit is a square root of the max number, because if you really think about it, there is no point in going beyond the square, since beyond the square there will be, like, you know, actual beyond square root, because beyond the square root there will be actual squares of numbers that you have already, and squares are composite by default, so you already kind of crossed them out, so you don't have to go there. And then yeah, that's how it goes. And I believe that the biggest improvement here is actually this limit, obviously, and that you are skipping here. This is I times I, this is I times I believe. No, this is I times 2, right? This is I times 2. Also, you do I times 2, not plus I, because you don't want to kind of check every number, because if you check every kind of multiple, some of those multiples will be still like even multiples, right? So you only want to check odd multiples. That's why you iterate plus I times 2, or I shifted to the left. Yeah, so that's the algorithm, and yeah, that's pretty neat, I think. I don't know how to exit this mode, which is funny, but you might believe me that it works in about 50 milliseconds for 70 million, and the answer is correct here. So I believe that's pretty cool. Can I please, thank you, exit. So let's try, let's see where we're at. Yeah, that's how my folder with studies looks, with angry face and a skull. And now there is an exam. Yeah, it's 50 milliseconds, as I said. Sometimes it's slower, sometimes it's higher. You know, it's okay. Now I feel embarrassed, but believe me, sometimes it's slower actually. But I believe that 50 is a good estimate here. So it's pretty cool, I think. I don't know if it's like the most performant one, but yeah, that's why I optimize this. I believe that this is like the coolest part about it, because I only store the odd numbers here, right? I don't store even numbers, makes no sense to store them. I only store odd numbers here. So we have like 1 million of integers, which is a lot. But it's not in a stack, it's like in a data section. So it's not that bad, I think. So it's just the binary that's like super huge, right? I believe, or something like that. Well, not really binary, but yeah. And yeah, I basically access them with this ID. You can easily check that if you want to only access like the odd numbers from 3 onwards, like basically 3 minus 1 divided by 2. I mean, number minus 3 divided by 2. And then, yeah, basically you always use this ID to index this big array. And then you do some kind of division here to get the correct bracket, so the correct integer. And then you get also here correct bit index, so correct index of the bits. I go from the left to the right, so it's like kind of unintuitive, because you usually go from the right to the left, but I think it's like kind of smarter to go from the left to the right in this case. I mean, for me it's easier to visualize it in my head. I guess it's not that important. Maybe you can even optimize it like even further, I'm not really sure. But yeah, that's how I'm doing it right now. So yeah, that's my solution. I will probably submit it to because our lecturer actually organized this contest, like who will submit the fastest solution. So that's pretty cool, I think. I don't know if this is the fastest solution, but that's certainly my solution, and I think that's what counts here. And also I try to, when I can, I try to use like better C++, so there's like this cool format function. Like generally speaking, format is such a great function. And I'm using std, so I didn't do the std out. If you want to crucify me for using namespace, do. But this is a one file program, so I believe it's not that important, like parent namespaces. Okay, I need to check quickly when is my bus, because my car is wrecked and I can't use my car right now. I need to get it to the workshop. However, I need to. I don't know even how. I mean, it's wrecked. Okay. It was lovely talking to you guys. Nobody watched me, which is like funny, but I'm getting used to that, I suppose. So yeah, I'll be just. I think I'll just convert it to a video about the Sieve, and yeah, I'll see you guys probably later when I'll be grinding or like reading or something, learning. Keep the grind, man, and yeah.